Hello everyone. Let's take a look at our next problem. Compute the integral of x secant x tan x. Okay, so my first instinct here right away is that I think I know the antiderivative of secant x tan x. It is secant x. So the derivative of secant x is secant tan. So I know how to integrate that, and I know how to differentiate that. So this looks like a straight up integration by parts problem. So if I'll write out all the substitutions here used for integration by parts. And then I have, just by substituting things into the integration by parts formula, I have that. And I believe, so I've done this integral not too long ago, maybe 2 or 3 weeks ago, the integral of secant. And I'm pretty sure, if I remember correctly, the antiderivative is something strange looking. Some of you might think this is kind of standard, something that you typically memorize. I believe that's correct, but I'm just going to check to make sure that when I differentiate the logarithm of secant plus tan, that I get secant. Yeah, so this all works out. And this is the answer to our original problem. There are a whole bunch of different ways of deriving the antiderivative of secant and showing that it's this logarithm of secant x plus tan x. And I think there are even other ways of writing this. You might be able to use some trig identities to write that in a different way. But this will work. So yeah. I was fortunate that as soon as I saw the problem, I immediately identified something that I already know how to integrate. And if it's multiplied by something straightforward, in this case just x, then integration by parts is kind of the immediate go-to. Thanks for watching.